This is Newt, my second omnidirectional robot, this time using a specialized form of Omni wheels called Mecanum wheels. Stick around and I'll show you how it was designed, programmed, and built. For the CAD model of this project, I started with the body of the robot, which will house the control board, battery, and motors. Then I began modeling up the Mecanum wheels. If you're interested in designing these yourself, there are plenty of resources online that will explain the process in detail, so I'm just going to give a brief overview of how I did it. I started by sketching some polygons parallel to each other and centered on the wheel axle. In my case, I used nonagons since I want the wheel to have 9 rollers. Then I used a point from each of these polygons and the center point of the wheel to create a 3-point plane and sketch the profile of the roller. For this, I used the connecting line between the polygons as the axle and the construction circles to define the arc of the roller at its midpoint and both endpoints. Then I could use this profile to revolve first the PLA core and then the TPU tire of the roller. Using a circular pattern around the wheel allowed me to generate the remaining 8 rollers. Next, I started modeling up the core of the wheel in 2 halves that would bolt together. I used an offset plane to sketch the mounting features of the roller and also pattern these around the wheel. Finally, I could mirror the wheel across the center planes of the robot to generate the remaining 3 Mecanum wheels. Since I'm using stepper motors again for the drive of this robot, the code is very similar to the code I use for TURT. I have the Excel stepper library to control the speed of my drive motors, and the RF24 library to handle radio communication. Here I read in the commanded translational motion, rotational motion, and speed from the remote, and here I calculate the unique speed for each of the motors to achieve the desired motion. For my last project, I used these 5-volt stepper motors commonly used in electronics projects, but I wasn't very impressed with their power. So for this project, I decided to upgrade to these larger NEMA 17 stepper motors that should provide more speed and torque. But since these motors require more power, they should be driven by a dedicated stepper driver. To keep the wiring simple, I'm going to be using a CNC shield to interface these stepper drivers with the Arduino. As you can see, Newt has all the omnidirectional capabilities of my last robot with some distinct advantages. This design is more capable of going over bumps and through difficult terrains because all 4 wheels face the same direction and can be driven like traditional wheels. This comes with a caveat that the Mecanum wheels are more difficult to design and assemble than normal Omni wheels. While the upgraded stepper motors for this design provided improved speed and torque compared to TURT, they draw a significant amount of current, even while sitting still, leading to a short battery life. This could be improved upon by instead using brush motors as an encoder for speed control, which I plan on implementing in a future video.